Then let's come to the final speaker before we start the panel. So we're very happy to have Xusheng Wang. Dr. Wang is the Senior Director, Global Product Management and Technology Integration at Canadian Solar, and he's overseeing it along the value chain. And he will let us know how the new era of reliable high-efficiency modules with 200 millimeter based Series 7 looks at Canadian Solar. The floor is yours, Xusheng.
Okay, thanks for the introduction. Yeah, so first I will share my screen. Okay. So this is Xusheng from Canadian Solar. And today I will begin my presentation with the topic, the new era of a reliable efficiency module, 2 millimeter based Series 7. So first, I would like to have a brief introduction of the company, Canadian Solar. And Canadian Solar is a global player with 19 years experience. Our modules already shipped more than 150 countries, and the total module shipment is beyond 50 gigawatt. So what we see here is we have a very long history in PV. We start our company back to 2002. So you see every year our shipment gradually increases, and last year, 2020, the shipment is around 12 gigawatt. And the Canadian Solar is a top-tier bankable solar module supplier. We are among the most bankable module supplier by BNEF. Our bankability is around 100% compared with our competitors. And this 100% bankability already lasts for 6 consecutive years. And we are always a technology leader. For 2008, we are the first to introduce 6-inch cell modules, and in 2010, we already developed the dual cell modules and also double glass modules. So we have a very long history to deal with dual cell design and the double glass manufacturing, and now it's the mainstream product. And back to 2015, we are the first company to introduce the black silicon cell technology into our multi-module production. And 2017, we combined the 5BB dual cell with the bifacial module. And 2018, we introduced the 160 cell size, and the module power is beyond 400 watts. And we are also the first one to turn poly into poly-PERC. And 2019, we are focused on high efficiency mono-PERC and the custody mono-PERC. So this is our past. And now we are developed into a new era, which is, say, we bring the products, the module power up to 500 watt, 600 watt. So Series 7 is the name of our new module. We believe it brings a new era. So first, let's take a look at our module appearance. So on the left, you see is the monofacial modules. We have 2 kinds of modules. One is a smaller, another is a bigger one. So for the smaller one, the power is up to 600 watt. And for the big one, the power is up to 665 watt. And on the right, you see is the bifacial modules. So you'll see the front side and also the back side. And the power is also up to close to 600 watt and 655 watt. And here we have the conclusion, what's the characteristics of our Series 7 module. So the first is the module power is very high. It's almost the highest power you can find on the market. As I mentioned before, it's 665 watts. The module efficiency is also very high. It's up to 21.4 because we are taking the most up-to-date cell technologies for PERC. And the cell efficiency is up to beyond 23%. So in this way, module efficiency can be up to 21.4. And we studied a lot on LTID performance. So we know how to control LTID from wafer, from cell, and we have the regeneration extra process on the cell level. So the LTID is very suppressed, and it's 50% lower compared with the average industrial level. The hotspot temperature is also well controlled. We have a special method on the cell level to control the hotspot temperature. We believe our module hotspot temperature can be 40 centigrade degree lower compared with the industrial average level. Also, we are trying to minimize the micro crack impact on the module level. This means we need to deal very carefully on the wafer, on the cell, and on the module manufacturing. So we ensure the micro crack is controlled within the lowest level. Also, the mechanical load is straight designed. We can meet the highest level on the market, which is 5,400 Pascal. Because it's based on 210 millimeter wafer, the current is very, very high. Also, the module size is very, very high. It's very, very big. So it's compatible with the mainstream tracker. We already discussed widely with the tracker supplier. Also, we discussed widely with the mainstream inverter supplier. So it's also compatible. And we did a careful calculation on the LCOE and BOS, which is the lowest level we can achieve. And we believe the product will be very competitive on the market. So let's go to details. The first part is the high reliability. So here, what I show here is the excellent hotspot performance on the module level. So we see we have a red line here, which is 170 degrees. Beyond that line, the module will have a very higher level risk on the hotspot issues. And so this is the issue we see from our competitors. And because we have the control on the cell level, so we see for our Series 7, which I mentioned here, our hotspot temperature can be controlled beyond below 140 and even 130. So compared with our competitors, we are 40 degrees lower, which means our module is much safe in the real field. How to control it? Because we have CSIR technologies. This technology is invented by Canadian Solar, and we use it on the cell level to sort out the cell we don't want on the module. So this is the way to prevent hotspot risk originated, which may from localized leakage current at the cell level, which you always find this kind of cell. So on the picture you see here, the industrial average is very high, and for Canadian Solar, we are in a very safety zone, and it's the temperature is lower. Also, we have advanced regeneration technologies to provide the industry lowest LTID. Compared with our competitors, say, take example, if we test for 96 hours, the industry standard is around 1.5%. And our Haiku 7, Series 7 module is just 0.8, which is just the half of the industrial level. If you test more, say up to 500 hours, you can see we are still perform the half for the industrial level. Our Canadian Solar is just 1.2, and for the industry average, it's 2.5. The second part is the higher module efficiency. In the past, we set 3 records for cell efficiency. Back to 2019, we set a record which is 22.28 for H-pattern P5 cell with 9BB design. This is certified by Fraunhofer. And then the left 2 is certified by ISFH. And the middle one, 22.8, is also a cell with H-pattern P5, solar cell with 9BB. So the efficiency is as high as 22.8. The last one is 23.8, is N-type P5 for bifacial solar cell. And this means we works a lot on the cell level to introduce lots of new technologies inside. And we have very unique heterotype ribbons and paving technologies on the module level. You see the industry average is will have more than 2 millimeter cell space on the modules. So sometimes you see a very wide gap. But on Canadian Solar Series 7, you see a very small gap. The cell space is below 0.7 millimeter. And this means the cell gap is 70% decreased. And in this way, we can increase the module efficiency a lot. Higher module performance. Our module shows a better low iridescence performance, which will bring around 0.5 higher energy yield. So the industry average is 1.8. The module loss at low irradiation level, 200 watts per meter square. Our Canadian Solar Series 7 is 1.3, so the absolute value is 0.5% lower, and the relative value is 28%. Now I will talk about more on the low balance of system cost. For the electric system, we discussed a lot with all the inverter suppliers. Say, for the first category, the central inverter, we discussed with companies like Sungrow, SMA, Power Electronics, and FEMA. And all the results lead to those inverters are compatible with our Series 7 module, which means you have no, say, it is okay. And regarding the string inverters, we discussed with Sungrow, Solis, SMA, and Huawei, and their feedback is also okay. They already signed letters to Canadian Solar, which means they can supply the inverters together with our Series 7 modules. And for the central inverters, using our Series 7 module, we will have fewer strings and shorter string wiring, and also fewer or simpler combiner boxes. For the string inverters, you will also have fewer strings and shorter string wiring. And the recommended layout is, say, 1 string per MPPT. And also, we will have improved monitoring, and also more reliable against faults and reverse current. So Haiku 7 gives you more than 20 kilowatt per 1,500 VDC string. On the mechanical system, our module is compatible with the tracker suppliers. For 1P tracker, we discussed with Nextracker, Array Technologies, Arctic Solar, and PVH. For the first 3 companies, they are compatible with our modules. For the last one, they claimed Q1 this year, they will be compatible with our module. Our module will be launched, will be available from April this year, so the time is okay for us. For 2P application, Nextracker is okay. Arctic Solar is also okay. For Soltech, will be ready from Q1 with our bifacial modules. For the first two, it's okay. For PVH, all the modules will be compatible also in Q1. So don't worry about the inverters and the trackers, which is compatible with the 210 modules. Also, thanks to low VOC, we have even higher power per string. Our standard string is based on 166 module, which is 3W. The string power is up to 12.5 kilowatt. And here also I put 182 module in the middle. The power is a little higher compared with 166. It's up to 16.4 kilowatts. And the last one is our module we promoted today, which is based on 210. And the power is up to 20.2 kilowatts. It's the highest compared with 182 and even higher compared with 166. The cost is the cost improvements. So what we see is everything is much reduced, including the tuck tube, purlins, posts, modules, and the work. The baseline is still 166 module 3W. And I also put 182 module in the middle. By the comparison, 182 is also better compared with 166. But 210 module is the best. You see, we have 14% lower cost on the tuck tube, up to 31% lower on purlins, and on models is also 37%. On modules is 31%. Although also the work is 11%. The last part, I will talk about the BiHaiku 7, which is the bifacial module, and TaiyangSolar is a bifacial leader. So all the bifacial modules passed the IEC standard test, and we passed 3 times IEC standard stress test. We show a very better performance of the glass-glass bifacial module compared with the monofacial ones using the PID, on the dynamic load, on the DH2000, on the TC600, bifacial modules, all performance better or much better compared with the standard monofacial modules. And we build lots of bifacial testing sites worldwide, including North America, USA, and also China, also Australia. Here we can take examples, say in USA, we in the location Boulder, we have a 14 kilowatt testing site built. Albedo ratio is around 0.23, and we use the next tracker. And we tracked the module performance around 10 months, and we see the bifacial modules generate 7.8 much electricity compared with the standard one. So in every location, we have this kind of number shown here, and you see the bifacial gains can be from 6% up to 15% here. So if you choose the bifacial modules, it will give you more power generation. Also, Series 7, we have much lower BOS. So here we can see, compared with the standard modules, on the module level, we have 28% lower on the labor cost. Also on the structure, we have 14% material cost down, and the installation cost down is up to 35%. Foundations are 66% foundation material cost up, but the installation is cost down by 4%. And the soft costs, we have, say, 4% EPC/OH, civil workers. And for DC EBOS, we have, say, 8% save on DC material cost decrease and up to 39% DC labor cost down. For AC e-bus, we are the same with the inverter and MV, HV, and the station cost. So totally, we have 5.7 lower BOS. Also, the lifetime electricity generation can be as high as 25.7 higher. So here we have the standard module based on 166, which is, say, the lifetime power generation is 46.9. And for Haiku 7, the single facial module is 47.1, which is 0.4% higher. But for the bifacial one, we generate much, much more, which is up to 25.7%. The absolute value is 59. LCOE is also much lowered compared with the standard 166 module. The single facial module, the LCOE is 3.5% lower, and for the bifacial module is 8.9% lower. The absolute value is here for the standard one is $30.9 per million watts, and for Haiku 7 is 29.8, and for Haiku 7 is 28.2. So last one, our module will be available from April this year, and as a conclusion, it's high power and also high efficiency, which I mentioned in the previous slides. 665 watts and 21.4%. We believe the module will come with very high reliability. We have our spatial technologies like CSIR, CSAR technology, and we are using HDR ripples. And from LCOE, it's the lowest on the market, and we believe compared with the standard modules you can buy now, is the bifacial modules can save the LCOE up to 8.9%. Okay, so this is all my presentation, and thank you for your attention.
Thanks, Xusheng. Very nice. Maybe just, I think we're now back fully in time, but let's maybe have 1-2 questions directly to your presentation. When you mentioned the record efficiencies, can you actually also say what kind of cell technologies you are working on?
Okay. Okay. The cell technology is PERC. Actually, it's a custom mono PERC. So the previous two technology, the previous two records is custom mono PERC, which is 22.2 and 22.8. The last one is N-type custom mono PERC. It's 23.8.
Okay, that's fine. And then the next generation you are looking into is
okay. So the next technology Canadian locked into is TOPCon and the HAT. We have a TOPCon R&D line in our factory, and we are benchmark the max production possibilities of TOPCon. Also, we already built a HAT pipeline in another location, and it's a cell pipeline and the module pipeline. The capacity is around 250 megawatt. So we'll see which one we need to choose in the future, whether it's TOPCon or HAT.
Okay, perfect. I think we still have a bit to do on the module side.